Hello guys and welcome to my channel Machine Learning Papers Simplified, where I will try to explain machine learning papers in a very simple manner which can be understood by machine learning practitioners as well as beginners alike. Today I will discuss a very famous paper in computer vision popularly known as Alexnet, otherwise officially known as ImageNet with deep convolutional neural networks. This paper is regarded as a milestone paper in the field of computer vision. Let's try to understand just why. This paper entered in 2010 ImageNet Large Scale Visual Recognition Challenge, where it achieved top 1 and top 5 score of 37.5 and 17.5 respectively. Now what is top 1 and top 5 error rate? Let's try to understand that. Top 1 error occurs when model fails to correctly classify the image in its first attempt. Whereas if the model fails to correctly classify the image in 5 consecutive attempts, it will contribute to top 5 error. So obviously top 5 error will be less than top 1 error, as model will be able to at least correctly classify the image in 5 consecutive attempts rather than first attempt. In 2012, Alexnet again entered the ImageNet Large-Scale Visual Recognition Challenge, where it achieved top 5 error rate of 15.3%, whereas the runner-up had a similar score of 26.2%. So, Alexnet almost bettered the next best model by 10%. So this speaks volume about Alexnet design. Now let's talk about the authors of this paper. So this is the ImageNet trio guys. On extreme right we have Jeffrey Hinton. On extreme left we have Ilya Sutskever, and then in middle we have Alex Krzyzewski, who is also the designer of this model. This is Jeffrey Hinton. He is also called as godfather of deep learning. He was associated with University of Toronto when this paper was written. Then we have Ilya Sutskever. He has also written other famous papers like sequence to sequence model, as well as he is the co-author of TensorFlow. And finally, this is Alex Krzyzewski, who, as we discussed earlier, is the designer of this model. In one interview, it was asked to him, why did he design this model? He said he designed AlexNet because he wanted to write earlier famous model called as LeeNet, which was designed by Jan LeCun using GPUs. Now let's talk about the ImageNet dataset. Original dataset has around 15 million images with close to 22,000 classes. However, in the competition, a subset of this dataset is provided which has around 1.2 million images, and the number of classes that we need to predict are 1000. This data also has 50,000 validation images as well as 150,000 test data images. Now, in paper it is written that they only performed one kind of data preprocessing, which is to subtract mean from all pixels of image. They implemented a number of different strategies to achieve state-of-the-art performance. Let's discuss them now. Firstly, they tried to run the model parallelly using two GPUs. Each GPU was GTX 580 having around 3 GB of RAM. Since each GPU had max RAM of 3 GB, so the number of neurons which can be generated is also limited. Thus, parallel computing was necessary to train a large number of neurons simultaneously. Other change which they did was to use ReLU instead of TANH as the activation function, since ReLU trains 5 times faster than TANH. In this figure, you can see solid line is ReLU whereas dashed line is TANH. So, it shows that ReLU is almost 5 times faster than TANH. Other trick which they used was using overlapping pooling. It means that one kernel overlapped the next one. This helped to reduce overfitting. They also used augmentation methods like image translation and horizontal reflection. In this method, they took random patches of size 224 by 224 from the images. Other augmentation which they used was to alter intensity of RGB pixels during training. Finally, they also used dropout of 0.5% for generalization. Let us now discuss Alexnet architecture. Overall, it has 5 convolutional layers followed by 3 feed-forward neural net layers, thus a total of 8 sequential layers. Not all layers take input from all previous layers. For instance, layer 3 takes input from all kernels of layer 2 from both GPUs, but layer 4 takes input from layer 3 for only those kernels which reside in same GPU. Now, this architecture was bettered only in 2015 by Microsoft's deep learning model having around 100 layers. So, as you can see, that input size of image is 224 by 224 having 3 channels for RGB. First conv layer has 96 kernels split across 2 GPUs. Each kernel is of size 11 by 11 and stride is of size 4. Second layer has 256 kernels of size 5 by 5. So 48 channels are available as 96 channels are split across 2 GPUs. Third layer has 386 kernels of size 3 by 3. Fourth layer has 384 kernels of size 3 by 3, followed by fifth layer having 256 kernels of size 3 by 3. This completes 5 layer CNN architecture. This is followed by 3 dense feed-forward hidden layers having 4096 neurons each. Thus you can see from this figure guys that only third layer is taking inputs from all kernels of second layer. Otherwise, rest of the layers only take inputs from those layers which reside in same GPU. Feed forward is an exception as it takes input from all the neurons. This completes overall architecture of Alexnet. Numerous CNN-based models have their roots in Alexnet. That is why it is regarded as such a great as well as a milestone paper in field of computer vision. Do let me know your views as well as suggestions in comments below. Till next video, take care and bye.